Mathematics, Chapter 2, Polynomials, Class 10 CBSE, Exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. For discussing this topic, first we'll discuss some concepts. Okay. So here we are assuming a quadratic equation, that is a polynomial equation, ax square plus bx plus c equals to 0, and we are assuming that the solutions of these equations are alpha and beta. So the sum of the zeros or solutions will be equals to minus b upon a, or we can say minus of coefficient of x upon coefficient of x square. Okay, and product of the zeros will be equals to c upon a, that means constant term upon coefficient of x square. So just remember these two formulas. Now if we are representing the sum of the zeros alpha plus beta by s and product of the zeros by p, then we can write quadratic equation using the formula x square minus sx plus p is equals to 0. So you should remember this formula also. Okay, clear? We will use this formula in our numericals. So let's see first numerical. First numerical is x square minus 2x minus 8. Okay, now we will solve this numerical. X square minus 2x minus 8, we can write this by doing the factors of these equations, and factors are x minus 4 into x plus 2, and we are equating it equals to 0. So we will get here sums will be 4 and minus 2. Okay, now you can see here x minus 4 is equals to 0 and x plus 2 is also equals to 0. So we will get the solutions x equals to 4 and minus 2. Now sum of the zeros are denoted by alpha plus beta, and that one is equals to minus b upon a, and we are saying that minus b upon a is minus of coefficient of x upon coefficient of x square. Okay, so alpha plus beta, we have solutions. Alpha is 4 and beta is minus 2. So we'll get here sum of these quantities, that means 4 plus minus 2 will get 2. Okay, so in our equation we'll check sum of the zeros is 2 or not. This one is 2, you can see here. Okay, now next one is product of zeros, that means alpha into beta. Now product of zeros will be equals to c upon a, and that one is equals to, according to this numerical, 4 into minus 2 will get minus 8. Now check in the equation, you can see here product of the zeros is equals to minus 8. Okay, so this is the correct solutions for this equation. Okay, 4 and minus 2 are the correct solutions. Now second numerical, 4s square minus 4s plus 1, and we can write it like this, 2s minus 1's whole square. Okay, so the solutions in this case will be s is equals to half and half, because we'll get two positive solutions. This is a quadratic equation. Okay, so our solutions are half and half, or we can say the values of alpha and beta both are equals to half and half. Okay, so in this case we'll check the sum of the zeros. Sum of the zeros will be equals to alpha plus beta, that means half plus half will be equals to 1. Okay, and the product of the zeros will be equals to 1 by 4, or we can say 1 by 2 into 1 by 2 will get 1 by 4. Okay, now for checking the equation, in this equation we say that x square minus alpha plus beta into x plus alpha beta is equals to, this one is the quadratic equation. So we are replacing the values over here. 1 by alpha plus beta's value is 1, so we can replace 1 into x, and alpha into beta's value is 1 by 4, that one is equals to 0. Okay, now next equation is 6x square minus 3 minus 7x. So first of all we'll rearrange this equation and we can write it 6x square minus 7x minus 3. Okay, now we'll do factors. So you can see factors of this equation will be equal 3x plus 1 into 2x minus 3. Okay, so equating this equation to 0, we'll get x equals to minus 1 by 3 and x equals to 3 by 2. So these are our zeros, or we can say solutions. Clear? So here we got two zeros or two solutions. Now we'll find the sum of these zeros. Okay, that means alpha plus beta. So you can see alpha plus beta, the sum of these two quantities, we can add this one 1 by 3 plus 3 by 2. So we'll take here the LCM 6, and this one will be minus 2 plus 9, and this one will be equals to 7 by 6. Okay, so alpha plus beta will be equal to 7 by 6. Again, the product of zeros, that means alpha into beta, will be equals to multiplication of this, will get 1 by minus 1 by 3 into 3 by 2, then we'll get 1 by 2. Okay, so you can see here alpha plus beta is equals to 7 by 6 and alpha beta is equals to minus 1 by 2. Clear? Now you can cross check putting these values in equation. X square minus alpha plus beta into x plus alpha beta is equals to 0. Clear? So if you put the values, these values in this equation, you will get the original equation. Now next numerical, 4u square plus 8u. Here the constant term is equals to 0, so we are putting here 0. Again, for finding the solution of this equation, we'll take common quantities outside the bracket. Here we'll take 4u as a common, so we'll get 4u into u plus 2, and we are equating it equals to 0, so u will be equals to 0 and minus 2. So we'll get two solutions or two sums, or we can say two zeros. Okay, so now we'll do sum of the zeros, that is alpha plus beta. Okay, so putting the values of alpha and beta, 0 plus minus 2 will get minus 2. Okay, next one is product of zeros, alpha beta will be equals to 0 into minus 2 will get 0. Clear? Now you can see in the equation, alpha plus beta is equals to -2 and alpha into beta is equals to 0. Okay, so in this equation you can see for u into u plus 2 plus 0, you can see this equation. Okay, if we'll put the values of sum of zeros and product of the zeros in equation x square minus alpha plus beta into x plus alpha beta is equals to 0, then we'll get the original equation, this one. Clear? Now next numerical is t square minus 15. So we'll do factor of this equation. So we'll get, first of all we'll use the formula a square minus b square equals to 0. So we can write it like this: a plus b into a minus b, and we'll equating it equals to 0 for getting the solutions. Okay, clear? Now you can see this equation is in the form of t square minus under root 15 square. So we can expand it like this: a minus b into a plus b. Clear? And then after we'll equating it equals to 0. So we'll get two solutions. First solutions will be t equals to under root 15 and second will be under root minus of under root 15. So we'll get two solutions or two zeros. Clear? And you can see here two solutions are t equals to under root 15 and t equals to minus under root of 15. Clear? So now we'll calculate the sum of the zeros, that is alpha plus beta. Okay, so we are putting the values alpha and beta, then we'll get 0 here. Okay, because alpha is equals to under root 15 and beta is equals to minus of under root of 15. Now next case, product of 0, that means alpha into beta. So under root 15 into minus of under root 15 will get minus of 15. Clear? So you can see here this one is minus 15. So if you'll put these values in equation x square minus alpha plus beta into x plus alpha beta is equals to 0, then you will get the original equation. Now next one is 3x square minus x minus 4. So first of all we'll do factors of this equation, and factors are 3x minus 4 into x plus 1. And now for calculating the solutions we'll equate it equals to 0. So we'll get two solutions. First one is x equals to 4 by 3 and second one is x equals to minus 1. Okay, or we can denote it by alpha and beta. This one is alpha and this one is beta. Okay, now we'll calculate the sum of the zeros, that means alpha plus beta. So adding these two quantities 4 by 3 plus minus 1. Okay, now LCM is 3, 4 minus 3 will be equals to 1 by 3. Now the sum of the zeros will be equals to 1 by 3. Okay, now we'll calculate the product of the zeros, that is alpha into beta will be equals to 4 by 3 into minus 1, or we'll get it equals to minus 4 by 3. Clear? Now for getting the original equation, you replace these values in x square minus alpha plus beta into x plus alpha into beta. If you replace these values in this equation, you will get the original equation. Clear?